and your 20 minutes starts now.
Thank you very much, Keith, and welcome again to this presentation. So I take the title from a famous book by Cressida Cowell, which is about dragons, how to train your dragons. But we're not talking about dragons, we'll be talking about data and machine learning and artificial intelligence today. So let me first of all give you a very brief introduction about the company and what we do. So HyperDAP stands for Hyper Data Analysis Platform. And I founded the company early in 2019 during the Grey Matters 3 program. Now, I don't know if everyone is familiar with this program, but it's a joint initiative between Elevators and the Scottish Enterprise, OGDC, BP, and PPT, Production and Exploration, in order to gear the creation of new businesses and support in support of the energy industry. So, as I was part of this program, I've seen so many experienced people with so many good ideas and business propositions. What I felt was needed and was missing was somebody that could properly translate expertise into software. That's why I pulled a team of experts in artificial intelligence, machine learning, software engineering, and full stack development to support the industry and get revenue from their data, capitalize from the data. So what we have done since the beginning, we have developed tools for big data sets, visualization, automated analysis, and interpretation. So let me just after this presentation, we talk about what the layout of this presentation is. So I'm not going through that slide again. And what I'm going to do now is I'm going to put you out of your comfort zone for a few slides. And then Anthony will present some light at the end of the tunnel. So let me just get straight into this one. So the road to computing hell is paved with silver bullets. What does it mean? Well, effectively, the history of commercial programming languages, high-level programming languages, is paved with silver bullets. So I will not go through in details the history, but I will just highlight the main points. So starting from 1960, with the famous COBOL and Fortran. So some of you may have heard about those high-level programming languages. Some of you may have already used in their work. And effectively, it must have been a really an exciting time when the first product was issued with these languages. It was the first time that the machine was taking over the humans. However, a typical program would have had 200 lines of codes at that time. If we compare with now, just Microsoft Office has around 10 million lines of code. So we can start seeing immediately the difference between the beginning and now. And then all the other decades, and you may have heard about all the other advancements were created in order to meet the expectations. So although at the beginning, people were marketing COBOL and Fortran say, oh, that is going to solve all the problems, they realized that that was not the case. So they had to go into the next level and so on and so forth. So I've just highlighted a few of the major steps in the computing advancement, which were always, as soon as they were published, the message was, this is going to solve the problem. Possibly not, partially. I mean, there were some applications that did, some other they don't. Now, if we go straight into now, we have artificial intelligence, machine learning, and NoSQL database, big data and analytics. Question is at the moment, are these ones the solution for everything? Question mark. So we can't talk about the artificial intelligence without talking about the data first. So is the data silver bullet? Again, in the past we used to say, oh, don't waste my money, my time, because time is money. We don't hear that any longer. But the new mantra is now data is the most valuable asset of your company. Possibly. Or would it be people, actually? And we'll talk about that later on, because that is an important point. Indeed, we are surrounded by a huge amount of data, and there is knowledge inside the data, and the knowledge leads to competitive advantage if you're a business and profitability. We can't discuss that. It's a fact. The problem is we are sitting under an underground ocean of data. We don't see the data. We don't perceive the data. There's nothing we can see every day. We know it's there, and possibly we are very keen to fish into this ocean and start gathering insight. And is it possible? Is it really happening? I'll go straight into the next point, which is the numerical data quality significance. And I'm talking about that because for me, it's a critical element. And it's also very, very close to us, to HyperDAP, because we are running a major project about novel algorithms to assess the data quality and suggest automated improvements, which is called IDQI. We may talk about that later on. Is the intelligent data quality improvement. So quality of data. If you look at the picture now, which one would you buy? Would you buy the left one or the right one? And obviously the answer is I'll buy the right one, because has a good definition, it's a good picture, I can use it for my passport to share with friends and so on and so forth. This is what quality is. We can't assign a value to quality unless we know exactly what the quality means. So I'm talking about numerical data set in this context, and this is just for the purpose of this presentation. So numerical data set, we must have quantity, measure, quality in place. So one, again, the two major parts of this discussion are, first of all, data is affected by uncertainty. So the bigger the uncertainty is, the lower the quality is. And then again, we are tempted to compare the value we have with what we expect to have. And the difference, obviously, is the bigger the difference is between expectation and reality, the lower the quality is. So going into the next one, what can go wrong? Effectively, uncertainty is often overlooked. We don't consider that as much as we should. Very often, quality is measured with qualitative metrics rather than quantitative metrics. And then we are comparing the number of good points with all the points. And one of the most common solution is, if I had to describe the quality of my data set, I would say 80% of the data is good. So we are effectively doing a percentage. So I will use 80%, maybe I'll discard 20%, but I'm afraid this is not enough. So going straight into artificial intelligence, and then Anthony will expand that a little bit more. Again, artificial intelligence wasn't born yesterday. So I can quote the first high-level programming language, which is Lisp, 1959. And again, the history of computing goes together with the history of artificial intelligence. Every decade there is a new discovery. The problem is what he's discovered is definitely a huge improvement, a fantastic improvement. However, the more complex you go, the more expectation you create, and the more you have to do in order to meet more further needs. So we are going straight into the last bullet point: machine learning as intelligent data mining from now on. Is this a silver bullet? Is solving all the problems we may have on big data sets? So Pitfalls, again, the famous sentence which another mantra, you may have heard that so many times: garbage in, garbage out. It's true. However, artificial intelligence can help you greatly to get fantastic results, but you need to take into consideration that your first step is to have a good quality data set from the beginning. Artificial intelligence means that all the algorithms and calculations are performed by the machine and not the humans, and the machine will learn from the human expertise. So the training set must be adequate. If you don't train the machine properly, you will not have proper results. Same as in the algorithms. Algorithms must be correct. And when we say algorithms, because the whole process is step by step. So the algorithm needs to be created together with the subject matter expert in order to be fit for purpose. If you don't do that, then you have problems. Then at the very end of the process, you have to reassess the performance of the system constantly. If this is not done properly or is incomplete, you may end up with something which is not up to the level you want and is not up to the standard. And at this point, I will pass the baton to Anthony, who will explain you a bit more about AI. Please, Anthony, the floor is yours.
Thank you very much. So just as Nicoletta mentioned, that the data is so important to what you want to accomplish when you want to use any of the machine learning or AI methods, we also want to put across the notion of how the new technologies get taken and used by experts in the industry and used for whatever purposes you have in mind. So right now, in terms of AI and in industrial factory work, there's something called Industry 4.0. And this is the fourth milestone in industrial revolutions, where a technology has been taken by an industry and exploited to benefit, its own profitability. And just like all the other technologies in the past, first it has to be developed, in academic or otherwise. And then it gets noticed by the industry and exploited, which is a good thing. So what I want to put across here is that machine learning, data mining, and other types of artificial intelligence should be exploited by various experts from, or various expertise and for various purposes within whatever industry you are in. And just as it's important to make sure that the data that you use is good, it's also important that the expert has a huge input into how the mining or the learning takes place. So I don't know everyone's background here, all of the invisible audience members. I don't know your background, so I just want to talk about a couple of concepts in computing that have been not misunderstood, but a couple of points have been disregarded previously. So probably you've all heard of supervised versus unsupervised learning. And if you haven't, then a supervised versus unsupervised learning means that the learning that happens gets guided or isn't guided by the human. But this doesn't mean that the developer or an expert in whatever field the learning is taking place isn't guided. So the initial starting point of the learning has to be, well, I keep repeating the word guided because it has to be initialized by the expert or the developer. So if the expert doesn't have big enough input into what it is that they're looking for or what it is that they're interested in, then the developers will have to use their own judgment, which as a general rule, they're not going to be as knowledgeable in whatever area that they're looking into as the expert themselves. So they may not exploit the initial learning as well as it should be. And so what would happen is that the learning takes a little bit longer than it should, or it starts looking for different things that you would want it to be looking for. And then what happens there is that the outcomes from the learning are not as optimized as they should be. So expert input is it should be in your, should be a big priority whenever you're looking at data mining or inputting machine learning into anything you do. Can we go to the next slide, please, Nicoletta? So the most successful strategy for any artificial learning is that the human expert in whatever field you are expert in, you should be able to create what we'll call here a library of your knowledge. And this is everything and anything that makes you an expert in your field. So whether it is looking at very specific things, or whether it is setting a set of rules that make you come to the decisions that you come in, and then all of these need to be communicated to the developers or to the company developing the software, and which is one of our expertise is taking in expert knowledge and then translating that to learning software. And then, so once you've created these libraries of your knowledge, which don't have to be absolute, they can evolve over time, and then you have to indicate some of the initial points of interest or the initial things that you would be interested in, the analysis or the interpretation or whatever it is the task at hand is, for the learning to have an initial starting point. If you imagine a student who's learning as much as they can, he's going to learn more, or he's going to know more after a few weeks if he has a really good textbook that has a lot of information in it, than if they had to learn a lot of this stuff without much guidance to begin with. So once the learning has had some initial points of interest, then we can create some assessment performance tests, or it can be either automated for unsupervised learning, or it can be guided by the developers for supervised learning. But these assessment performances need to have a large input from the experts, so that the developers know exactly how they can judge whether the learning is progressing or not. And then, depending on the performance values of these assessments, we can adjust the learning depending on what the expert is interested in. And this is one of the best strategies, because you specialize in a task just for whatever it is that you're looking for. We've talked very broadly on this, but this is without going into specific tasks and into specific industries. That's how the learning should take place. And that's it for now from me. Back to Nicoletta.
Thank you, Anthony. So let me just recap on this presentation and just highlight the takeaways. So first of all, the first main suggestion is have a good data set. So apply effective quantitative metrics on your numerical data set, first of all. And then obviously artificial intelligence and machine learning, which is a subset of artificial intelligence, by the way, it will give you the option to choose between the best solution that fits for purpose and is in the context. Obviously, you need to be prepared to be dynamic and agile in terms of flexibility. And coming back to the first things we said before, the quality of a machine learning solution is as good as the collaboration between good developers and good knowledge experts. So we back to people. So people will be your best asset. And in combining the two things, we may have discovered the mythical chemical ingredient to turn lead into gold. So thank you very much for your attention. And we would love to know more about your experience with data and your data needs. Thank you. Over to you, Keith.
Excellent. Well, thank you very much, Nicoletta and Anthony. That was a really good overview of machine learning, artificial intelligence, and data analytics. So I would just like to invite any of the participants who are listening in to ask any questions. So I can either unmute you if you have a question, or you can type it into the chat function. And just whilst we're waiting for that, I'm going to kick off by asking a question myself. So Nicoletta or Anthony, can you give us maybe a little bit of an overview on what you see the uptake is across different industries? Obviously, a lot of the participants today will be from the oil and gas industry, and we're an industry that has lots of data from various technologies, and how well we use that data, I guess can be argued is sometimes not very well. So how do you see between the oil and gas industry and other industries out there the use of machine learning and artificial intelligence? Is it something that we use more than other industries, or could we be better at what we're doing?
Well, thank you for this. Is a really good question, Keith. And my personal belief and experience in this area is that overall, if we're talking about the amount of data which is generated worldwide, it's so big that I can't even pronounce it, honestly, as we are talking at zettabytes of data. A zettabyte is equivalent of 10 at the power of 21. So you write 1 and then you add 21 zeros, if I remember correctly. Well, there is an organization, a European organization, which is the Big Data Value Association. They have quantified the value of the data, and they reckon that by end of 2020, worldwide, the value of the data is going to reach 100 billions of pounds. Why are we talking about the value of the data? Because oil and gas, I'm coming from a oil and gas experience. I've been working in the hydrocarbon allocation and data management systems for production and the reserves. So that is my background. This is where we've developed the first product within the oil and gas industry. But in the principles are there. We don't apply enough machine learning, we don't apply enough artificial intelligence. And this is also the message that the same association has given to the European Commission, saying that, well, we're talking about Europe. I know UK is not part of Europe any longer, but geographically, we're still part of this area of the world. So making reference to them, they published white papers saying, we don't apply that enough. And that is across the various industry. We can say confidently, this is not the case for oil and gas. There is a really an incredible drive to open to artificial intelligence, machine learning. There are still some misconceptions and some barriers that we need to still fight. One of the barriers is the fact that people still do not trust enough artificial intelligence and machine learning, thinking that they are overtaking the humans. But actually, I wanted to demonstrate with my presentation that this is not the case. Actually, it's the opposite. The machine needs the humans more than what the humans needs the machine. So there's still an awful lot to do. But then we do have the capabilities to do it, and we need to embrace the call.
No. Can I add something on that as well? Yeah, so especially the oil and gas industry, it used to have so much surplus money that a lot of companies decided, right, we're going to spend a lot of this money on data acquisition, and we're going to record as much data as we can, and we're going to store as much data as we can, because one day it's going to be super useful. And the thing is that now we're coming to the point where it's too much data for a human to analyze, right? Because when you speak to most people about data analysis, they imagine some sort of visual representation of the data, and then a human going through it and looking at it and extracting information from it. But the thing is, we have so much data, and computers are now becoming so good at analyzing them that we should, or the oil and gas industry should focus a lot more than it has on automated analysis, because that is exactly what computers were made to do. You know, they weren't made to distinguish the difference between an umbrella and a walking stick, right? Which is a classical AI example, but they are specifically made to calculate differences between numbers and look at numbers and highlight, you know, things that happen. That's exactly what they were bred to do. But from my experience, the oil and gas industry has spent so much time recording information and data, and almost, you know, not 1% of that effort was into automated analysis. There's lots of visualization tools out there, but you haven't scratched the surface of automated learning.
Yeah, no, thanks for that comprehensive answer, Nicoletta and Anthony. I think it highlights a point that we have lots of data out there. It's extracting the value from that data that's important.
Yeah.
Going forward. We've got a good question coming from Ernie Lamzat. So he's asking, could you give me an example of what you do in HyperDAP and how that can add value to my business?
Okay, thank you, Ernie, for your question. I founded the company early January 2019, so it was a little bit more than 1.5 years ago. What we have done so far is, just to give you an example of what it's the two major developments which were linked to a specific problem. So the problem was, or let's say the needs of a client to analyze huge data sets coming from fiber optics. And we are talking about distributed temperature sensing data. So what we have created for the engineering firm who commissioned us the tool is something which is a very straightforward visualization tool, and on top of that, automated analysis and interpretation. So I'm repeating a little bit myself, as I said in the presentation, but more in details. What we have done, we have enabled the client to use a simple tool and extract the information automatically, drastically reducing the time of analysis, and also giving the possibility to extract analysis and information that the humans may not see. So let me make an example. You may have seen other visualization tools where the data is displayed more or less like in Excel format. You have trends, you have zones where you can zoom in and look at the data. And the data can be coded, color coded, for example, which is very popular, which is very common, and you see areas of interest. So what you want to know from your data, what are the parts of your data that are giving you the information, because from a huge data sets, you may have parts which are okay and not giving you much information, and parts which are more critical. And this is what we call areas of interest, because these are the parts that may replicate themselves. These are the phenomena you want to analyze, you want to pin down and extract in order to do future proof or make predictions or understand what happened at that time in that particular area. So everything is done by the machine. So even if a human eye is good at capturing some of these phenomena, may not be good enough for capturing all the phenomena. So you are missing an important part. So the benefit for the industry and the benefit by using these tools is that you can extract information that otherwise would have been lost by a by a manual analysis only. And that is the beauty, the thing. The benefits is effectively incredible for the industry. Now, I cannot quantify in terms of money. We're not into that sort of details, but in terms of time spent, minimum time spent for analysis compared to manual analysis, which may take weeks, if not months, and is done by the machine in hours. And then you discover more than what you could have discovered yourself, even if you are an expert. So that is to give an indication. And again, we worked very closely with an engineering firm and with the major operators in the North Sea. And that was the example and what we've mainly done. We've done that in stages. So effectively, I'm talking about a couple of projects, and there will be a follow-up of the project from the operator's point of view with a specific user trial. Yeah,
we're essentially a really well-rounded software development company. So we have specialists in data mining, in machine learning, full stack development, data cleansing, you know. So it's quite hard to give an example on how we can add value to a specific business when we don't know what the business is or your specific problems. But if you have a large data set that you would like to exploit for information, and you would like to do so in the most efficient way possible, that's what we do best. You know, we collaborate with various specialists from whatever field. You know, we've got lots of projects in lots of different areas, and then we develop analysis and interpretation. That's our biggest, the biggest point we want to put across is that we develop automated analysis and interpretation software so that you can exploit your data sets without the added labor-intensive process of doing the things yourself, when a computer can do it 100, 200 times the speed. Yeah.
Great. Thanks for that, Anthony and Nicoletta. Can I ask, is there any more questions from our audience? If you just want to raise your hand or like we say, use the chat function. I think I've got one final question I'd like to ask, and then we'll maybe wrap up and let you get on with your day, Nicoletta and Anthony. But one of the questions I had, looking at the oil and gas industry, we are obviously interested in maximising economic recovery, but we're also interested in achieving a net zero basin in the North Sea. How do you see that a company like HyperDAP and data management and artificial intelligence and machine learning could assist, especially, I guess, with our drive towards net zero? Do you think there's opportunities within that?
There are indeed opportunities. The less we do manually and the more we let the machine to do, the more time is saved for other tasks. This is quite a simple statement, but effectively that is the truth. So if we infuse the human expertise into a software, and then we discover more, we may discover more and optimize our own processes and make the expertise of the humans more effective and more let's say, driven to results. So I would say net zero is a really, again, it's a really another hot topic of discussion. Oil and gas industry, I believe, has got a lot to do before we reach real results on net zero. But if you optimize your processes, you are in the right track. How can you optimize your processes? It's only if you optimize your data assessment and you plan better. It's a very long and convoluted link between net zero and software. It's not really a straight route, but in supporting that, we can support the organizations to achieve better in less time with better results and saving resources. And when I'm saying saving resources, because the human resources are effectively invaluable and they can be used for more complex and engaging tasks. And optimization, definitely tools like what we have developed in HyperDAP can greatly boost the optimization of your processes, industrial processes as well. Again, we are talking very vaguely, but there is a direct link of how much we can do in terms of automation and how much humans can do in terms of applying automation and get optimized results.
Great, thanks for that, Nicoletta. Yeah, I totally agree. I think process efficiency and optimization definitely has a huge part to play in achieving our net zero goal and maximizing economic recovery in the North Sea. One question has came in again from Ernie Lamza, and he's saying, Nicoletta mentioned IDQI. What is it and what benefit will it provide?
So IDQI is the acronym of Intelligent Data Quality Improver, and it's actually a big project which we started last year, and it's sponsored by the Data Lab and the former OGIC, Oil and Gas Innovation Center, and now is Heriot-Watt University. And the work is focused on creation of novel algorithms and calculations to create effective metrics for data quality assessment and improve automatic improvements. So we are creating metrics and adding artificial intelligence in order to reveal the quality and suggest improvements for big data set quality. The collaboration is between HyperDAP and University of Aberdeen Computing Science Department, and we are working, they are developing the metrics and the new algorithms. So that will be another stepping stone. And what we reckon is important here, because I think I've highlighted enough the importance of having a huge data sets. It's not only because of garbage in and garbage out, because effectively it's how good your data set is dictates not only just the results, but also the knowledge, the wisdom, and effectively the profitability of your data. So what we reckon is after the project will be completed, and we are talking about a few months more, we will publish the results, and that will be the integration of any other tools we are going to develop. So there will be a specific part of our knowledge that will be made available to the industry and to the public. Like a module integration of any software that can drastically improve the quality of your data before processing.
Great, thank you for that, Nicoletta. So we're just getting towards the end of our time there. Could I ask you to flick onto the next slide if that's okay, Nicoletta? Yeah, so I'd just like to kind of wrap up for today and thank Nicoletta and Anthony for joining us. That was a really kind of informative presentation you gave, very kind of thought-provoking. And obviously I'd like to thank everybody that's joined us today in the audience. Thanks for your participation and listening in. Hopefully you've learned something for a Friday morning. And yeah, if you just have a look at the QR code on the slide there, if you want to take a scan of that. I know that Nicoletta and Anthony will be keeping an eye on socials, LinkedIn and Twitter. So if you've got any other questions, feel free to post them in there, and we'll do our best to get some answers to you. So the next Tech20 is scheduled for next Friday at 11 AM. So keep your eye out for the upcoming topic and sign up for that. That'd be really appreciated. And if you're going to put anything on socials about Tech20, if you use hashtag Tech20 Virtual or hashtag Time to Tech20. But again, thank you everybody for joining us, and I'll leave you to get on with the rest of your Friday and have a great weekend. Thanks.
Thank you.
Thanks. Bye-bye.